Today on Green Science Oregon, we're taking a good look at the future of solar energy. A group of students at Oregon State University has formed their very own solar vehicle team. We'll take a look at their latest vehicle and learn how constructing the solar car was a combined group effort. We'll also visit OSU's School of Chemical, Biological, and Environmental Engineering, and the OPIC Lab, where laboratory research is being done to develop thin-film solar cells. One method being used prints a solar energy absorbing solution onto any surface. All coming up next on Green Science Oregon.
My name is Hai-Yu Han, and I am the co-captain and chief engineer of the OSU Solar Car team.
This is a project involving Oregon State University students to design, build, and race solar-powered vehicles. We're working on our second vehicle. We started the team in 2005. It was actually Hai-Yu who had the idea to start the solar vehicle team from a movie he saw when he was 16. And so he practiced all through high school and for the first part of his university career making electric go-karts for practice making solar-powered cars.
Actually, Hai-Yu, we should just pull one of the calipers off. It'll be like 10 times quieter.
Where's Eric? When I was in high school, when I was a sophomore in high school, my brother found a movie about high school team, or a group of high school students starting a solar car team and taking their solar car on a solar car race. And I was like, hey, that sounds like a lot of fun. I want to go do that. But it was not as easy as I thought in high school. So I kept that in the back burner until I came to college, and when I came to college, I started the OSU Electrothon team, which is a team that built like a electric go-kart that was in preparation for a solar car team. And in 2005, me and Kathy, the other co-captain, we started the OSU Solar Car team, and since then, we produced 2 cars.
So this vehicle started out as a design of a body that would fit around a person, and then we had to design a frame to fit inside that for structural integrity. We began by building this titanium frame, which was mostly welded and bent to make this frame. And then we also made the carbon fiber body, but we had to make a mold and a plug for the body, which are really, really large pieces that are kind of shaped like the car to make this carbon fiber body. Those were the major structural components, but then on top of that we had to assemble a battery pack. We had to acquire a motor and motor controller and design a lot of the electronics that controls the vehicle. And we also were donated from Solar World, we were donated 700 bare solar cells to make this solar array, and so we cut, soldered, laminated, and strung together the solar array.
This solar car is a inverted tricycle design, meaning it has 2 wheels in the front and a single tire in the back. We only have 3 wheels to improve the frictional drag of the car. Having 3 wheels creates less friction than 4. We actually have a Star Trek touch interface on our steering wheel. We're one of the only cars that has a LCD touch control interface instead of like a mechanical on-off switch for a lot of its controls. Having an LCD touchscreen interface allows us to have fewer wires in our car, which in turn means higher reliability all the way around. It weighs about 440 pounds. It's got a carbon fiber body and a titanium chassis. We're actually one of the only solar car teams that has a titanium chassis because titanium is usually very expensive, right? But we have our our local sponsors from ATI Pachang, who has given us more than $24,000 of titanium for our car. So our car was able to have the same strength with half the weight for a typical chassis. The power input on a solar car on a bright sunny day is about 2/3 the power of a hairdryer. So a hairdryer is 18,000 or 1,800 watts. Our solar car takes in about 1,000 watts peak. And so with this power, our car is able to go on the highways and attain highway speeds. When this car closes down, you will see that our car is a very small frontal area with a very small coefficient of drag. So it is designed to cut through the air. The actual shape of the car is actually based on an airfoil design. If you look on the side view of the car, it actually is the same profile as like an airplane. Actually, you see, and we actually had to perform calculations to ensure that our car does not fly when we're driving.
Green Science Oregon is brought to you by Oregon State University, where faculty, students, and research are powered by Orange. Have an idea for an episode of Green Science Oregon? Send it to us. Go online to greenscienceoregon.com and click on the contact page.
Wow, that smells. Is it the e-brake?
The e-brake was sitting on the wheel a little bit.
That's okay.
So I think we've just turned our tire into a slick, but
You start that.
Rubber.
Oh, stinky.
we can see this settled down
Oh, did it?
on the tire when we lifted it up.
We have a group of approximately 20 to 25 like core students, and we have students from every field, from electrical engineering, mechanical engineering, to history and geology and everything in between. We take everybody.
The team means a lot to us personally, in that this is just the beginning of a life that we want to have involving alternative transportation and education around alternative transportation.
My name's Danielle and I helped assemble the solar array. We cut them at OHP using a laser cutter and then soldered them together with bus bars and created the solar panels, which are 12 cells for each one. We soldered 6 half cells in a series and then attached them with a bypass diode and did another 6, so each panel has 12 half cells. And then we have 7 sub-arrays on the car. There's 1,030 half cells on the car, or 515 full cells.
I'm Eric Hyde, and I'm a mechanical engineering senior at Oregon State University, and I work on the solar vehicle. Part of what I do here in the solar car, I started off with a lot of the body mechanics and working on constructing the body, and then I moved on to design and implementation. I'm working with several other people on a senior project team to upgrade the latch system, lift system, and the wheel fairings on the solar car. We've been doing a lot of finite element analysis in SolidWorks in order to make sure our components work before we actually build them. And we've been having a lot of fun doing it.
My name's David O'Gorman. I was the chief electrical engineer for the OSU solar vehicle team. So for this vehicle, we had to design all the electronics ourselves. I mean, there are things that are commonly available that could kind of do what we needed them to do, but for the skill set we had available for the team and for the amount of funding, it was most efficient and not very difficult overall for us to design all the vehicle electronics ourselves. We made one unit that monitors the charge and discharge of all the batteries in the vehicle for a very large pack of lithium-ion batteries. There were clear rules about how it had to be monitored so that things wouldn't catch fire and be used most efficiently. We had to make all the electronics for controlling the motor ourselves, and then we had to make the electronics for just body housekeeping functions like the turn signals, horn, all that sort of thing. This is actually the body control module board here. It was designed by some of the people on the team. It was a modular design. These are our processor carriers. They carry the smarts for the vehicle. It hooks to an in-vehicle network that communicates between all the circuit boards and the control computer for them. All the different lights and sounds on the vehicle plug in here. All the motor controls plug in here, and then the vehicle network plugs in here. After these boards were designed, we sent them out, they came back, and they were actually manufactured here by the students and members of the team. This whole house was converted over to the solar car production facility. Basically, we took over the kitchen table for all the circuit board construction. We had students working in there, putting together the circuit boards, troubleshooting the circuit boards. This area here was used for solar cell assembly. The area over there was solar cell testing, and just piles of material and students working long hours for the last month or two before the trip to get things ready.
Right now what we have is a dedicated group of students, a good solar-powered car, and a lot of potential for outreach and improvement on the solar-powered car. So our current goal is to get as many people involved as possible, to get a lot of publicity, kind of show people what we're doing here, and to bring in a lot more students so that they can have experience with hands-on projects like this. Because there is no other hands-on electric vehicle research at OSU. And so if students want to graduate their program being aware of the intricacies that go into making electric vehicles, they really do need to work on a project like this to get that experience, and that's where a lot of the major car companies are going. Our goal is to continue to improve this vehicle, maybe make some of the less efficient components more efficient, fix up some of the things that we don't like about it, change the designs a little bit, but since we have the major structure, it's not going to be as expensive as an undertaking as making the first version of this car, and just to get more people involved.
Green Science Oregon is brought to you by Oregon State University, where faculty, students, and research are powered by Orange.